Hi, everybody. One of the hottest topics this fall has been AI in the RAN. We've all seen the big announcements from Nvidia, and we know that there's a lot of activity underfoot. So today, I'm happy to be speaking with Cole Crawford of Vapor IO, who has really interesting news on this topic. Cole, tell us, what's going on?
Yeah, thanks for having me, Jim. We are announcing in partnership with Supermicro and the city of Las Vegas, the world's first private 5G AI RAN deployment. AI being artificial intelligence, radio access network being the RAN component, and we'll be deploying this on top of NVIDIA's AI aerial platform. Um, we have clearly spent years building network infrastructure in Las Vegas. So this zero gap platform, which sits on top of this fiber footprint, this data center footprint that we spent years zoning and developing, we're building this capability out with the city and for the city and its services, starting with computer vision capabilities, but extending and permeating into a number of different city scale applications over the coming years. Really exciting.
Yeah, so walk us through this. So you have your Vapor IO data centers out at the edge, and who's going to be the customer for this new AI
The
RAN
city itself,
capabilities?
the city itself is our customer.
Okay, and what about the carriers?
So carriers could end up being customers of this. We believe in the power of network augmentation. So you look at T-Mobile as an example, right? They've recently partnered with Nvidia on AI aerial as well. We hand off traffic to T-Mobile in Las Vegas. So if you can, for both the carrier, the over-the-top cloud provider, content provider, et cetera, if you can lower latency, decrease the transit transport, backhaul costs um, by handing traffic off closer to the user and using infrastructure like this AI-enabled aerial infrastructure on the MGX platform, which allows you to combine the same physical hardware that runs your inferencing capabilities, right, your AI workloads, as well as the network itself. You empower the telco, you empower the citizen, you empower the enterprises that are present inside of the geographic boundaries of that city or municipality. Um, and you empower the city itself to do far more interesting things than the sort of monolithic infrastructure that we've been putting up to date.
Yeah, so let's walk through the components then, one at a time. So tell me about the stack that you have offered.
Right. Well, the running joke in telco land is it takes wires to offer wireless. Um, so while there's a lot of AI, there's also a lot of fiber, and there's fiber has to terminate inside of a building. So there's data centers, and Vapor's built multiple data centers across the city. We co-locate in multiple more data centers across the city to make sure that we've got multi-path, resiliency and redundancy on the physical infrastructure. And that's something that Vapor announced years and years ago. We called that the kinetic grid, right? So data in motion, lots of route resiliency, lots of local fiber-centric backbones that sit on top of our optical layer, right? So we run our own optics. Um, in February, we launched Zero Gap as a platform. Zero Gap is an accelerated cloud offering. Right? This is a GPU as a service, bare metal cloud, software orchestration, et cetera, capability. Um, Today, we are announcing this 5G component, this AI aerial component to this, which combines everything we've built up until now, plus the ability to run a 5G core, build this AI automation directly into that radio access network. So this is largely a wireless extension of the zero gap platform that we've already built.
Okay, and then going back to the customer and the application, walk us through how that would work.
Yeah, so in this initial deployment, the city itself is our customer. This is going to be running on top of CBRS, which we have the ATO, the authority to operate in that market. We've partnered with a number of different back-end prioritized access license holders. And so this network runs on top of one of those PALs. And what this allows the city to do is it allows the economic development office, as an example, to go, monitor. And again, Jim, I'd love to show you and our audience here this capability. And if this comes out early enough on Monday, you want to see this demo, please stop by the Supermicro booth and do so. But imagine, if you will, a sensor in the form of a camera looking at the number of pedestrians at a certain intersection downtown.
Right.
And now your economic development council can go and say, hey, there is, as an example, several hundred women that are walking between, these hours and these hours. This would be a fantastic Ulta, Sephora, so some kind of retail shop. And the same could be true for a coffee shop on the corner. So you can use, economic development can use this. The city now has the ability, from a data sovereignty standpoint, to go embed this into, say, their new medical district, where as it's been announced, right? Vegas wants to be the next great place for cancer research and dynamic medicine, et cetera. So now there's a localized network where two different, say perhaps a genome sequencing company can be working with a life sciences company, and they can share data over an incredibly efficient, really fast network where the data never leaves that county. It sits, one hop away. Go ahead. Sorry.
So this is a method of offering a 5G core and an intelligent RAN for a city, for municipal operations, and it would be presumably cheaper and faster to roll this up compared to doing it through a carrier.
Well, I mean, whether you did it through a carrier or not, this is definitely cheaper. It's definitely faster, especially once this initial footprint gets built. Now, I mean, if you think about what needs to exist at the true edge, right? If most people think of a phone as like a device edge, well, this is just a radio signal. If that radio signal was attached to nothing more than an antenna and a camera sitting where it needed to sit, but the baseband unit, the actual radio itself, was terminated inside of, say, one of our data centers, that means your 5G to 6G upgrade, or your Grace Hopper to Grace Blackwell upgrade is nothing more than a server refresh, right? Sitting at no one has to climb a pole, no one has to take down expensive monolithic infrastructure at the top of a macro cell or a small cell. So definitely the speed at which these networks can be deployed, expanded, and then replaced and refreshed, with the economics tied into things like Open RAN, where we could, some of the network orchestration that we've built will allow for like seamless front haul handoff. So if we wanted to terminate a radio function or a VNF, virtual network function, in one physical location, and then spin that down in microseconds and up in a different place in another physical location because of our optical layer, completely possible, right? So that means potentially half the capex of your typical sort of wireless deployment.
All right, excellent. So it sounds like you have all of these interesting ingredients that you're putting together. Tell us about what are you showing then at MWC Las Vegas, and what does that tell us about coming ahead?
That's a great question. We will be showing a live inferencing capability, which obviously, if you were to replace that show floor with, say, a factory, right? The same kind of object detection. When you want to detect people, you want to detect machinery, you want to detect whatever it is you're detecting. Or because this is a big conference with lots of people running around, we're going to show people mostly. Nothing recorded, right? So it's nothing like that. But we'll show a live inferencing capability that would run at this edge on an edge network. And then we'll be showing how that network can be city scale for you. We're going to all be present in that building, right? But this extends to that entire city, and we've got other infrastructure that exists in that city. The the term I like to use for the overarching theme of this is the Internet of moving things. Phones move, right? We move across cities with our phones. Cars move. Um, Clothes move. Hard goods move. So from supply chain to logistics to real-time advertising, because people move. Uh, Building networks for this has traditionally been incredibly difficult. In fact, very few people know, Jim, that the reason why you have caching in YouTube is because we move around, right? So it's there to solve for the network inconsistency, not just of your wireline connection, even though those networks are very consistent. When you move from one macro cell, like one radio to another radio across like two different, um, propagation zones,
Right.
There's a period of time where you're watching video because you don't, cached video because you don't have a real time. Not dissimilar to this platform we're using. I was looking at Riverside. No frame drops, right? That's the big thing for Riverside. That
Exactly.
it's same thing exists here, right? You want to make sure that the quality of your data, the consistency of that data, the velocity of that data can support these mission critical workloads that are only enhanced when you start building in both, the inferencing side of AI, but also the training side of AI. So the Gen AI and the interaction through the models that have been deployed out at the edge, and you want to query those models.
Well, Cole, fantastic. I like this idea that AI RAN powering the Internet of Mobile Things. So thanks for sharing that with us today, and I'll see you in Las Vegas.
Sounds good. Thanks, Jim.